Nanoxaurus, often referred to as the polar bear lizard, represents a fascinating chapter in the evolutionary history of dinosaurs. Its discovery reshaped our understanding of how large predatory dinosaurs could adapt and thrive in extreme environments. This Arctic tyrannosaur was unearthed in one of the most remote and challenging excavation sites imaginable, the Prince Creek Formation in northern Alaska. This site is a treasure trove of late Cretaceous fossils, offering glimpses into a prehistoric world that defied conventional expectations. The initial discovery of Nanoxaurus wasn't a straightforward story of identification. When paleontologists first unearthed fragmentary remains, including parts of a skull and jaw, they were struck by its similarities to other members of the Tyrannosaur family. At first glance, it was thought to belong to one of the more well-known tyrannosaurs, such as Albertosaurus or Daspletosaurus. These genera had been found across various parts of North America and were known to roam territories much farther south than the Arctic Circle. As more detailed analysis was conducted, it became clear that the specimen had unique features that set it apart. Its narrow teeth, distinct cranial structure, and evidence of adaptations for cold climates hinted that it was not just a variation of an already known species. Instead, these traits pointed to the existence of a previously unknown genus. This realization led to its ultimate classification as Nanoxaurus, a name inspired by the Inuit word Nanook, meaning polar bear. The polar bear lizard had officially taken its place as one of the most intriguing members of the Tyrannosaur family. Nanoxaurus's classification within the Tyrannosaur lineage is a testament to the diversity and adaptability of this group of dinosaurs. Tyrannosaurs were some of the most dominant predators of the late Cretaceous period, with members like the iconic Tyrannosaurus rex reigning supreme in what is now North America. Nanoxaurus, however, represents a northern outpost of this evolutionary dynasty, adapted to the unique challenges of Arctic life. Detailed comparisons between Nanoxaurus and its more famous relative T. rex reveal both shared traits and distinct differences. Like T. rex, Nanoxaurus had an S-shaped neck, a robust skull, and diminutive yet powerful forearms. These shared traits are hallmarks of the Tyrannosaurina subfamily, to which both dinosaurs belong. The similarities in their skeletal structures suggest a close evolutionary relationship, with Nanoxaurus likely diverging from a common ancestor that also gave rise to T. rex and other tyrannosaurs. However, Nanoxaurus was not simply a smaller northern version of T. rex. It had evolved several unique adaptations that distinguished it from its southern relatives. One of the most notable differences was its narrower teeth, which may have been better suited for processing the specific prey available in its Arctic habitat. Additionally, certain features of its cranial structure suggested a lighter, more streamlined build, possibly an adaptation for hunting in the icy, treacherous landscapes of the north. Beyond its relationship to T. rex, Nanoxaurus also shares a kinship with other members of the Tyrannosaurinae subfamily, such as Daspletosaurus and Tarbosaurus, an Asian relative. This connection has fueled intriguing hypotheses about the evolutionary journey of Nanoxaurus. Some researchers propose that its ancestors migrated northward from other parts of North America, adapting to the Arctic environment over time. Others suggest a transcontinental origin, with its lineage tracing back to Asian tyrannosaurs that crossed the Bering Strait land bridge during periods of lower sea levels. The evolutionary placement of Nanoxaurus underscores the adaptability and resilience of tyrannosaurs. It demonstrates how this group of apex predators could colonize and thrive in environments ranging from temperate forests to frozen tundras, pushing the boundaries of what scientists once believed was possible for large dinosaurs. Nanoxaurus stands as a testament to the extraordinary biodiversity of the late Cretaceous and the dynamic evolutionary pathways that shaped life on Earth millions of years ago. The origins of Nanoxaurus remain one of the most intriguing aspects of its story, giving rise to multiple hypotheses about how such a formidable predator came to exist in the Arctic regions of ancient Earth. Understanding its evolutionary journey requires delving into the broader history of tyrannosaurs and their migration patterns, as well as analysing the specific environmental pressures that may have influenced its development into a unique genus. One prevailing hypothesis is that Nanuqsaurus descended from a North American lineage of tyrannosaurs. During the late Cretaceous period, the continent was home to a diverse array of these predators, with iconic species like Tyrannosaurus rex dominating the southern and central regions. Over time, it is believed that some tyrannosaurs ventured northward, following prey populations and exploiting new ecological niches. As these dinosaurs migrated, they would have encountered significantly different environmental conditions, particularly as they approached the Arctic. The colder temperatures, seasonal darkness, and unique prey dynamics likely exerted selective pressures that drove the evolution of specialized traits in these northern populations, eventually resulting in the emergence of Nanuqsaurus. Another compelling theory points to an Asian origin for Nanuqsaurus. During the late Cretaceous, North America and Asia were periodically connected by the Bering Land Bridge, a strip of land that emerged during periods of low sea levels. This connection facilitated the movement of various species between the continents, including dinosaurs. Some paleontologists suggest that Nanuqsaurus's ancestors may have originated in Asia, where they evolved under different conditions before migrating to the Arctic regions of North America. This hypothesis is supported by the discovery of closely related tyrannosaurs in Asia, such as Tarbosaurus, which shares some anatomical similarities with Nanuqsaurus. If this theory is correct, it suggests that Nanuqsaurus represents a northern offshoot of a broader transcontinental tyrannosaur lineage, highlighting the complex interplay of migration and evolution during the Cretaceous period. Regardless of its precise origins, the emergence of Nanuqsaurus underscores the adaptability of tyrannosaurs and their ability to conquer diverse environments. Whether it migrated from the south or crossed continents from the west, its journey to the Arctic was undoubtedly shaped by the challenges and opportunities of its time. The harsh climate and unique ecosystem of the Arctic demanded innovative solutions for survival, leading to the development of traits that set Nanuqsaurus apart from its relatives in warmer regions. The physical characteristics of Nanuqsaurus tell a fascinating story of adaptation to life in one of the most extreme environments of the late Cretaceous period. Like its relatives in the Tyrannosaur family, Nanuqsaurus exhibited many of the classic features that defined these apex predators. Its robust S-shaped neck supported a powerful skull, equipped with strong jaw muscles and serrated teeth designed for tearing through flesh and bone. Despite its relatively short arms, they were muscular and likely played a role in securing prey during hunting. These traits made Nanuqsaurus a fearsome predator, capable of taking down large herbivorous dinosaurs. However, Nanuqsaurus also possessed several unique features that distinguished it from its southern relatives. One of the most notable differences was the shape of its teeth. Unlike the thicker, more conical teeth of T-Rex, the teeth of Nanuqsaurus were narrower, suggesting a potential adaptation to a specific diet or prey type. This difference may have been influenced by the availability of prey in the Arctic, which included dinosaurs like Pachyrhinosaurus, a large herbivorous ceratopsian, and smaller hadrosaurs like Edmontosaurus. These prey species required specialized hunting techniques, and the narrower teeth of Nanuqsaurus may have been better suited for slicing through flesh with precision. The skull of Nanuqsaurus also exhibited unique cranial ridges and lighter structural elements compared to its southern counterparts. These adaptations may have contributed to a more streamlined build, allowing for greater agility and efficiency in the snowy, uneven terrain of the Arctic. Additionally, paleontologists have hypothesized that Nanuqsaurus may have been feathered, a feature increasingly recognized in many theropod dinosaurs. If true, this feathering would have provided essential insulation against the freezing temperatures of the Arctic, further emphasizing the dinosaur's remarkable ability to thrive in a challenging environment. Another intriguing aspect of Nanoxsaurus's physical characteristics is its potential sensory adaptations. Like other tyrannosaurs, it likely possessed an acute sense of smell, which would have been invaluable in locating prey across vast snowy expanses where visibility was limited. Its vision, too, was likely adapted to the low-light conditions of the Arctic, particularly during the long, dark winters when sunlight was scarce. These sensory enhancements would have given Nanoxsaurus a significant advantage in hunting and survival, solidifying its role as a dominant predator in its ecosystem. The combination of classic tyrannosaur traits and unique Arctic adaptations paints a vivid picture of Nanoxsaurus as a predator perfectly tailored to its environment. Its physical characteristics not only highlight the diversity within the tyrannosaur family, but also offer a glimpse into the incredible resilience and ingenuity of life in the prehistoric Arctic. The size and growth of Nanoxsaurus have been subjects of considerable interest and ongoing study, as they provide insights into how this Arctic predator compared to its tyrannosaur relatives and how it adapted to its challenging environment. When the first fossilized remains of Nanoxsaurus were uncovered, early size estimates placed it at approximately 6 meters in length and weighing around 1 ton. This initial classification portrayed it as significantly smaller than Tyrannosaurus rex, the largest and most iconic member of the tyrannosaur family. However, subsequent studies and comparisons with other tyrannosaur specimens have led to revised estimates, suggesting that Nanoxsaurus may have been larger and more robust than originally thought. Recent analyses of the fragmentary remains, including parts of the skull and jaw, indicate that adult Nanoxsaurus individuals could reach lengths of up to 9 meters and weigh as much as 3 tons. These findings elevate it from a mid-sized predator to one of the larger carnivorous dinosaurs of its time, capable of dominating the Arctic ecosystem. Some paleontologists have even speculated that under optimal conditions, Nanoxsaurus might have grown to exceed 10 meters in length, rivaling the size of smaller T-Rex specimens. This potential for substantial growth underscores its role as a top predator, capable of taking down large prey and competing with other formidable animals in its environment. The process of growth in Nanoxsaurus was likely influenced by the unique challenges of living in the Arctic. Tyrannosaurs, as a group, were known for their relatively rapid growth rates, with juveniles undergoing significant growth spurts during their teenage years before reaching full adult size. For Nanoxsaurus, this growth trajectory may have been further shaped by the seasonal availability of resources in its harsh environment. During the summer months, when prey was abundant, young Nanoxsaurus individuals may have experienced accelerated growth, building up the size and strength necessary to survive the leaner winter months. This seasonal pattern of growth would have been critical for juveniles, as their smaller size and lack of experience made them more vulnerable to both predators and the elements. Another factor that likely influenced the size of Nanoxsaurus was the abundance and type of prey available in its ecosystem. The Arctic during the late Cretaceous was home to a variety of herbivorous dinosaurs, including Pachyrhinosaurus, Edmontosaurus, and other hadrosaurs. These large herbivores provided a plentiful food source for adult Nanoxsaurus individuals, enabling them to grow to impressive sizes. The sheer size of some prey species, such as the heavily built Pachyrhinosaurus, suggests that Nanoxsaurus needed to be both strong and agile to successfully hunt and subdue its targets. This evolutionary pressure may have driven the development of a robust build and powerful musculature, enabling it to overpower prey much larger than itself. In addition to its physical size, Nanoxsaurus likely exhibited behavioral adaptations related to its growth and survival. Juvenile tyrannosaurs in other species are thought to have occupied different ecological niches than their adult counterparts, avoiding direct competition for food by targeting smaller prey. It is possible that young Nanoxsaurus individuals followed a similar strategy, focusing on smaller animals or scavenging carcasses until they grew large enough to take on the dominant role of apex predator. This division of ecological roles between juveniles and adults may have been a key factor in the species' success, allowing it to maximize resource use in an environment where food availability varied dramatically with the seasons. The ability of Nanoxsaurus to grow to such formidable sizes, despite the challenges of its Arctic habitat, highlights its adaptability and evolutionary ingenuity. Its growth patterns reflect a dynamic interplay between biology and environment, with its size and strength enabling it to thrive in one of the most extreme ecosystems of the late Cretaceous period. Further discoveries of additional fossil specimens may shed more light on the full range of sizes Nanoxsaurus achieved, as well as the specific factors that drove its growth and development. For now, the evidence paints a picture of a predator that not only survived, but thrived in one of the harshest environments on Earth, achieving a stature and dominance that cemented its place in the history of prehistoric life.